Hello students, right here again today. You're going to be doing some notes on section 3.3, Mixtures of Matter. Got three objectives. Make sure you understand these, be able to deal with them. Contrast mixtures and substances, classify mixtures as homogeneous or heterogeneous, and list and describe separation techniques. Got one review vocab term here. Substance, form of matter that has uniform and unchanging substances, also called a pure substance. I typically use that. Just substance, but substance, pure substance, same thing. As always, as you're taking notes here on this section, make sure you get everything you need. I'll just be hitting the highlights here from PowerPoint. You read the section, add any other things you need. And if you already have it in Hummer, don't necessarily need to write it down again, but it never hurts. Lots of new vocab terms as you go through this section. Make sure you get the definition, those definition for these. Main idea: most everyday matter occurs as mixtures, a combination of two or more substances. So here's our definition for mixture: combination of two or more pure substances, where each pure substance retains its individual chemical properties. We have homogeneous mixture. Composition is constant throughout. Homogeneous mixtures, also called solutions, so those will be used interchangeably. When we say solutions, we mean homogeneous mixture. Heterogeneous mixture, substances remain distinct. If it's a liquid, a homogeneous mixture or solution tends to be clear. Heterogeneous mixtures tend to be cloudy. You can have a lot of different systems and mixtures, as illustrated in this chart. Also find this chart in your textbook. But you can have gas, liquid, and so forth. And it just gives you a number of different examples of what's going on with each of these. We can separate mixtures. Filtration, technique that uses a porous barrier to separate a solid from a liquid in a heterogeneous mixture. We got distillation. Can be used to separate homogeneous mixtures. And a method called crystallization also can help separate homogeneous mixtures. So make sure you have these three definitions written out and have a general idea what we're talking about with each of those. A couple more: sublimation and chromatography. Again, write down these definitions, know a little about each of them. Get a little more explanation in the book on these, and you'll find some other things in the book not mentioned in this particular PowerPoint, but again, pull all these things out. Make sure you understand. Previously, we had talked a little bit about mixtures, and we have colloids, and we have suspensions. So, a lot of thing about mixtures, but just a little bit listed in this section. Little question here, couple questions I think. Which is not a technique for separating a homogeneous mixture? Oh, three of these other ones will, but filtration won't. Filtration only works on heterogeneous. Which is a heterogeneous mixture. Seawater would generally considered homogeneous. Sometimes some of these, depending on where you're getting and what you're talking about, could be either. This silver mercury is a homogeneous atmosphere. Again, we would generally consider to be homogeneous. But if you lived in a city and you had some smog floating around in your atmosphere, then it would be heterogeneous. But I would take the most common. It's salad dressing, the other one generally considered heterogeneous, but depending on what salad dressing they're actually talking about, some of them could be homogeneous. But most would be heterogeneous. So that's the best answer here. Not one of their best questions. So, get a quick little run through on section 3.3. Make sure you've read the textbook and add any other things in that we didn't mention here and weren't mentioned in Hummer notes.